Okay, hello everybody. Welcome to another review video. This one on Chapter 7 on Fundamentals of Heat Transfer by Bergman, Lavine, Incropera, and Dewitt. I'm going to start today by talking about Section 7.3. This is the methodology for solving convection problems. Okay, I think the most important thing you could do is focus on this section in studying for not only chapter 7, but for all of the convection chapters. Okay, so if I flip to methodology for convection calculation, we have one, recognize the geometry, right? So is it a flat plate, cylinder, or sphere? Okay, and then number 2 is specify reference temperature. 3 is calculate the Reynolds number. At least for two, 3. Yeah, okay, I apologize for that delay. Okay, so 1, specify geometry. 2, specify reference temperature. In the book, 3 has to do with mass transfer, but we're not talking about mass transfer. So in this video, 3 is going to be the Reynolds number. Okay, and then 4, local or average Nusselt number, and then 5 is pick correlation. 6 is solve for H. I mean, this is really, at least, especially for chapter 7, this is all you need to know, right? I think a lot of times we make the convection stuff a little bit more complicated than it really is, especially for external flow, which at least for me personally, I feel like I have a better grip on external flow than I do on internal flow and free convection, because it really is not too bad, right? So this is what you need to do for solve for H, right? So oftentimes what happens is we have some sort of system, right? And in this system, my personal system, it's a flat plate, right? And you could have some Q radiation coming in and some Q convection coming in. And then you could even have some Q conduction coming out, right? And so draw out an energy balance where you have H Ts minus, this would be T infinity minus Ts plus Q radiation is equal to Q conduction. Now, in solving this energy balance, you need to realize solve for H, right? So you get here, you realize I have to solve for H. So 1, flat plate. 2, specify reference temperature. Now, personally, I always just start with the film temperature. Okay, and let me just briefly show you what I mean by reference temperature. Okay, so if I come down here and I look in the book, table 7.7 is essentially a summary page of chapter 7, right? And it tells you the reference temperature and the conditions, right? So if I'm going to use this correlation, I need the film temperature. But if I'm going to use this one, this correlation, I need the free stream temperature, right? Personally, I always start with the film temperature because it's quite a bit more common to use the film temperature equations. But what happens is you can end up refining the model, right? So you start with T film, for example, all right? Then for here, you calculate the Reynolds number, right? Yep, calculate Reynolds number. And at TF, right? So the Reynolds number is equal to rho U L over mu or UL over nu. Okay, so okay, so if I look here, my Reynolds number, these properties, rho, mu, nu, they're dependent on Tref, and that is why it's important and crucial to calculate the reference temperature before you calculate the Reynolds number. Okay, and then after this, and then you ask yourself, is it laminar or turbulent, right? So if I come here, so I have a flat plate, I have my reference temperature, right, where the film temperature is often the T surface of the plate plus T infinity divided by 2. Calculate the Reynolds number. That tells me if it's laminar or turbulent. I can now go pick a correlation, right? And I can see that here, right? So for a flat plate, got the reference temperature, make sure you meet the conditions with the Reynolds number, the Prandtl number. If it's turbulent, you can use the 736, right? If it's laminar, then you would use something here, 730 or 732, right? Depending on if you need a average or local. All right, so we got the average or the local. What this allows us to, if you're looking at the whole plate, you'd use the average. If you're just looking at a part, you'd use the local. Okay, and then you use this definition, right, where you say the Nusselt is equal to HL over KF is equal to some correlation. Solve for H, plug in energy balance. And if TS is not known, then make a guess. And that's all there is to chapter 7. Okay, so essentially what generally happens is you draw an energy balance, you realize I need to calculate H. How do I calculate H? 1, is it a flat plate? Is it a sphere? Is it a cylinder? 2, specify the reference temperature. Like I said, I generally start with the film temperature. If I get to the correlation, then I realize I actually need to use T infinity, then I end up switching. It won't change, and then it'll end up converging in the end, right? But because T film is more common, I almost always use T film. Calculate the Reynolds temperature, and like I said, this underlined part, at the reference temperature, because everything that was highlighted in blue is dependent on the surface temperature, or sorry, the film temperature. Okay, and those are things that you look up in the back of the book, or you use Cool Props or the thermophysical properties calculator. Okay, and then this tells you if it's laminar or turbulent, right? So for a flat plate, the critical number Reynolds is about 5 times 10 to the 5th. And then for internal flow, or sorry, I believe it's oh, yeah, so 5 times 10 to the 5th for external flow is really what it is, I believe. That's something you'd want to check on though, because I believe it's 2300 for internal flow. Okay, all right, so geometry, calculate the reference temperature. If you don't know the surface temperature, if that's something you're solving for, make an initial guess. Calculate Reynolds number at the reference temperature, then decide if it's laminar or turbulent, and then decide if you need an average Nusselt, if you're looking at the whole plate, or the whole cylinder, or the whole sphere, or if you're just looking at one part, which would be the local, right? And then you use this definition right here, which I will highlight in this pink color. Nope, because that's really bad. Yellow. Solve for H, plug in the energy balance, and solve. And that's really use table 7.7, right? So if I had to think of 2 things that I would recommend, right? I would say use table 7.7 and methodology for solving convection problems. Okay, so those are the 2 things that I would focus on. Really, it just comes down to do an energy balance, realize you have to solve for H, look at your geometry, specify your reference temperature, decide if it's laminar or turbulent, if you need local or Nusselt, go to table 7.7, pick a correlation, solve for H, plug it in your energy balance, and solve for whatever you need out of your energy balance. That's really all there is to chapter 7. I hope this is somewhat helpful. And again, good luck on your exam.